Hi everybody, it's Mrs. Ellsworth, and yesterday we talked about ionic formulas, and today we're going to talk about covalent ones. And covalent ones are bonded where they share electrons. We drew Lewis dot structures of them, and so the covalent bonded ones, we're talking about molecules. Okay, so let's get started. Okay, so we started out with looking at some of these. Well, I got to tell you something. Molecules can be written a couple of different ways. They could be done with a structural formula like what we did with our Lewis dot structures, or they could be written in a more molecular formula, and there's also other ways of doing it too, but it's going to show all of the atoms that we have. If you're familiar with this at all and you'll think like, oh, we can reduce all these ones right here, molecules you cannot. You cannot. So molecules can't be reduced like ionic can. That's an empirical formula, and that's something totally different than the molecular formula that we're talking about. We won't be doing the structural formula right now either. We'll be strictly talking about that molecular formula. Okay, moving on. Okay, the neat thing about molecules is that they can have some pretty funky bonds. And so when we're looking at this, we can see that sometimes we'll have double bonds, triple bonds. I saw this depiction on here. I thought that was kind of cool how that they did that. And here is one showing those same exact elements with models showing those bonding. Okay, let's get started on this. So the neat thing about this is that there's no switcheroo, there's no nothing. In fact, this one I think is actually even simpler than the other one, but we just strictly use the prefixes. So you want to use this diagram, and it is located on your purple polyatomic ion chart in the bottom right of it, I believe. Anyway, it tells you, like, if you have a number, how many atoms that you have, what the number is, and what prefix that is. So we're kind of going to where we've got the name this time. We're going to write down the formula. So here we go. Now, carbon, there is no mono on the front of it because we don't write mono on the first one ever. And so, but we will write it on the second one, so you got to beware. Anyway, so it's carbon. Mono is understood. So it's just a C. Okay, and then mono means one. There's one oxygen here. Notice that these all have an IDE, even though that there are no ions in this. It still ends in IDE on the last word of them. Anyway, I'm sorry, I got sidetracked here. Mono means one and oxygen. So we don't write ones. Nope, we don't do that. So make sure that you just write CO on these. Oh, I can't erase that. Can't leave it like that. It just drives me crazy. Anyways, carbon again. It's got a mono understood here, so there's just one carbon. And di means two, so there's going to be two oxygens here. Notice I am not switching any numbers to the opposite element or anything like that. Okay, why don't you pause it here and go try out these next three on here. Okay, di means two, so there's two hydrogens, so H2. And then there's one oxygen here. Oh, wow, that's just water. Okay, carbon, there's just one here. And so it is mono, carbon, just one C. And then tetra means four. So there's four iodines. Okay, triphosphorus. Okay, so that means three phosphoruses. P3. And mono means one. And so that is just hydride, is just right there. Okay, these should make sense too, because some of them may even follow like the Lewis dot structures, how you know that there's four of them. I don't know why this one is like it is, but it is. There's just some covalent ones that can be very different, and some that are very easy to explain with the Lewis dot structures. Okay, now let's go backwards. Let's name these things. And so, and by the way, these all start with a non-metal. They all start with a non-metal. That's why you knew that it was a covalent one, why you knew it was a molecule, and that you had to use this covalent naming. Anyway, so there's one and one right here. We don't write mono on the first one, so it is just sulfur. Okay, and this is the one that students forget quite often with the monoxide here. Okay, I want you to pause it and try out all these. Okay, so this one would be sulfur dioxide. Okay, we did this one and the other one, so that's kind of like a bummer, but it's dihydrogen monoxide. Some of you may worry about capitalization on these. It's fine either way. They just have to be two separate words. Okay, carbon, 4 is tetra. Carbon, tetra, fluoride. Make sure you're spelling these things right. You got a periodic table to use for reference, so make sure you're doing that. Okay, and the second one always ends in IDE, and the first one always ends in its usual name. Okay, and then this right here be sulfur diiodide. Diiodide. Huh, does that look silly? But it's how it is. You don't do monoxide. For some reason, that right there, you don't do that. But you do here. Okay, and then we've got this one here could have been a gotcha. It's tri for 3 nitrogens, tri-nitrogen monoxide. Okay, that one that's got the one on it, watch out, that could be a stinker for some people, and so make sure you are looking carefully at those. And don't forget those monos on the second word. Okay, so we also need to be able to name the ionic ones too. So we're going back to ionic, and we're doing them backwards from what we did before. Okay, and these ones are lovely. There's no prefixes, but sometimes you got to worry about the Roman numerals on certain elements that are transition metals. So you got to worry about those ones. So here we go. Anyway, so this one here is going to be, hold on, is going to be sodium. And then go look for this guy in your purple polyatomic ion chart. That's capital O, capital H, and that's just going to be hydroxide. Okay, then we're going to skip over here to this one. Okay, this is copper. Copper can be a +2 or copper can be a +1. So you kind of got to unswitcheroo these ones that are made of transition metals. And you know that chlorine is a -1. It's got a 1 understood here, 1 understood there. So you know that copper has to be a +1. And so when they did the switcheroo of these, they didn't write the 2 1s. So let's go ahead and do this. You got to name this ion right here. It is this ion. So it is copper, Roman numeral 1, and then chloride. And this is one of those times that you must write a 1 in chemistry. You must, okay? But it's only to transition metals. We don't want to see any of them that have got a Roman numeral that are not transition metals that have more than 1 charge on them. So we definitely want to only see them when they're needed, and we don't want anything more written when it's not needed. Okay, so like the sodium here doesn't have a 1 there. That was not needed there. In fact, you should never put 1 there unless it's a transition metal. And notice that this goes with the transition metal. It never goes on the end of this. So don't put any craziness on the tail end of these things. Just put an IDE on them when it's a negative ion right there, which they always are negative, the second one. Okay, so let's go ahead and look at another one. Okay, like I had mentioned, that copper can be a +2 or +1. Maybe you can see that this one here is being unswitcherooed as a 2, and then a 1 is going up here, and that's good because chlorine is a 1, and so this is copper 2 chloride. Okay, back in the olden days, before we had the IUPAC naming system, these would be cuprous and cupric, and you had to know which one was the 1 and the 2 charge on it. But now we don't have to worry about that. We have the IUPAC naming, which everything always follows the same pattern every single time, and I love that. Okay, I want you to pause, and I want you to go ahead and figure out the other 3, and then check your work. Okay, so calcium. And this one here is oxalate. Wait a minute. I better just double check that one. Yep. Okay, calcium oxalate. And this one here is calcium. And it's not sulfur, it is sulfide. Okay, here's another one with a polyatomic ion. It's the one on the front, so it's ammonium. It is located after in the third column. Okay, and this right here is a +1 charge. It's the only one that's a +1 charge. It's the only one that's going to be on the front for us. Okay, so ammonium's the name of the first ion. The second ion is chloride. Don't do chlorine there. Do chloride. Okay. Okay, I want to look at another one that could be a real stinker. Okay, and let's go ahead and look at CuCO3. Okay, so this right here is copper. And again, we said that copper could be a +1 or copper could be a +2. Okay, well, these both look like that they've got 1 understoods right here. Okay, so this would be a -1 and this would be a +1. Okay, well, that's not true. If you go look up CO3 carbonate on your purple polyatomic ion chart, you'll see that it's actually a -2. Okay, well, what happened here? Well, this one was a +2. And so what happened was that they reduced out. It was a 2-to-2 ratio, and so they reduced out. So those ones I think are kind of stinkers, and that you've got to really watch out for them, because this right here is a copper 2, not a copper 1. And carbonate. So beware for those. Nickel, copper, chromium, those, and irons, those are some typical ones that you'll see that you got to worry about that Roman numeral. So beware about that, and then you are going to be assigned a yellow worksheet online, and so do your best on that. Okay? See you when I see you.